In this video, we'll learn how to manipulate equations using product of vectors. So here's the first problem. Let A vector, B vector, and C vector be three vectors such that mod of A vector is 3, mod of B vector is 4, and mod of C vector is 5. We know their magnitudes, and each one of them is perpendicular to the sum of the other two. So we know something about perpendicularity. And what do we need? We need to find the value of mod of A plus B plus C. We need to find the magnitude of the sum of these three. Now pause the video, try this on your own. Okay, so let's use the clues given in the question. A vector is perpendicular to B plus C. This means the dot product is 0. So we can say that A vector dot B vector plus C vector, A dot B plus C, that's equal to 0. Well, that's true for the other combinations as well. Each of them is perpendicular to the sum of the other two. This means B dot C plus A, that's also 0. And C dot A plus B, that's also 0. So we've got some idea of the dot products with each other. Alright, but do we know something about the dot products with themselves? Yes, we do. If we take A dot A, that's equal to mod of A square. But we know what mod of A is. That's 3. So A vector dot A vector, that's 3 square, that's 9. Similarly, B dot B, that's mod of B square, that's 16. And C dot C, that's mod of C square, that's 25. So we have some idea of the dot products with themselves as well. So we know A dot A, we know A dot B plus A dot C. So now we are in a good position to find A plus B plus C mod of this. So mod of this squared, that's equal to the dot product of this thing with itself. So this is equal to A plus B plus C dot A plus B plus C. And the reason we're doing this is because when you expand it, you'll get dot products of A with A, B, and C. And we already have values for most of these. So let's do that. Mod of A plus B plus C squared, that's equal to A dot A plus B dot B plus C dot C plus A dot B plus C plus B dot A plus C plus C dot A plus B. So we have these green values and we have these yellow values. Now let's look at what we have. These yellow values are all equal to 0. So this entire thing is equal to 0. And these green values are 9, 16, and 25. So this squared is equal to 9 plus 16 plus 25 plus 0 plus 0 plus 0. 9 plus 16 is 25 plus 25 is 50. So what we need is square root of 50. Let's solve one more. Three vectors A, B, and C satisfy the condition A plus B plus C is equal to 0. We need to evaluate mu, that's equal to A vector dot B vector, A dot B plus B dot C plus C dot A. So we need to find the value of this. And we're given that mod of A is 3, mod of B is 4, and mod of C is 2. Pause the video, try this on your own. Okay, so this time we know the value of A plus B plus C. So let's use that. Let's take the mod and square it. This is equal to A plus B plus C dot A plus B plus C dot of this vector with itself. So we can expand the right hand side. We have A dot A plus B dot B plus C dot C plus A dot B plus C plus B dot C plus A plus C dot A plus B. And do we know the green values? Yes, we do. A dot A is mod of A square, that's 9. This thing is 16 and this becomes 4. So 9 plus 16 plus 4. What about this yellow thing? Well, here we have A dot B and B dot A. So that's 2 times A dot B. Similarly, we have A dot C and C dot A. So 2 times A dot C. And we have B dot C and C dot B. So 2 times B dot C. So we have twice of what we need. We need A dot B plus B dot C plus C dot A. So this entire thing is mu. And what about the left hand side? A plus B plus C, that's the 0 vector. So the magnitude of that is 0. So we have on the right hand side 29, that's 20 plus 9 plus 2 times mu. Mu is what we need. And on the left hand side we have 0. So this is a simple equation with one variable. Mu is equal to minus 29 divided by 2. That's our answer. Let's solve one last problem. Alpha equals to 3i minus j, beta equals to 2i plus j minus 3k, And beta has been broken down into its two parts, beta 1 plus beta 2. And we're given clues about beta 1 and beta 2. Beta 1 is parallel to alpha and beta 2 is perpendicular to alpha. So in some sense, we're breaking down this vector into its two components. One component is parallel to alpha and the other one is perpendicular to alpha. Our job is to find these components. We have to find beta 1 and beta 2. And this is a useful skill that we'll use a lot in physics. So pause the video, try this on your own. Okay, let's do this together. Beta 1 is parallel to alpha, which means these two are collinear, which means we can write one of them in terms of a scalar multiple of the other. We can say that beta 1 is equal to lambda times alpha. It's some multiple of alpha. All right, this is beta 1. Now let's write beta 2 in terms of beta 1. So beta 2 is equal to beta minus beta 1. So that's beta minus lambda alpha. Because both of them add up to beta, we can write beta 2 as beta minus lambda alpha. Now what do we know about beta 2? So beta 2 is perpendicular to alpha. This means that the dot product with alpha has to be 0. So beta 2 dot alpha has to be 0. Now let's plug in values. Beta 2 is actually beta minus lambda alpha. So beta minus lambda alpha dot alpha is 0. Now this becomes beta dot alpha minus lambda times alpha dot alpha. That's alpha squared. And if you take the dot product with itself, it will give you mod of alpha squared. So this is equal to lambda times mod alpha squared. So this goes to the other side. So this is equal to beta dot alpha. Now let's look at this equation. We have mod of alpha square. This is something that we can figure out. And we have beta dot alpha. This is also something that we can figure out. And once we have these two, we can divide and find the value of lambda. So let's do that. Let's find beta dot alpha. That's 2i plus j minus 3k dot 3i minus j. So this becomes 2 times 3 is 6 plus 1 times minus 1, that's minus 1. So 6 minus 1 equals to 5. So now we know the dot product. Let's find alpha square, mod of alpha square. That's 9 plus 1, that's going to be 10. So this is 10 lambda equals to 5 or lambda equals to half. So once we have lambda, we can plug in these values and find beta 1 and beta 2. So let's do that. If we plug in lambda as half, so half of alpha, that's beta 1, that's half of 3i minus j, that's 1.5i minus 0.5j, that's beta 1. And beta 2 is beta minus beta 1. So the difference of beta and beta 1. So 2 minus 1.5, that's half I. And then 1 minus half j, that's 1.5j. And then we have minus 3k. So beta 1 is 1.5i minus 0.5j. And beta 2 is 0.5i plus 1.5j minus 3k.